Hey, so now we're going to get into writing functions. Now, when we talk about functions, we have already talked about domain and range, and we've looked at how writing x values versus y values can be kind of tricky. And so we've looked at things like discrete points and how we write those, and we write d is brackets 1, 2, 4, and 6, for example. If I wrote it continuously, it would look like -2 is less than or equal to x, which is less than 4. Yeah. So we're looking at discrete points plotted versus continuous. Same thing goes for range. We would look at something like this: brackets -1, 3, 6, and 9 versus -4 is less than or equal to y, which is less than 0. Or less than or equal to 0. So we're talking about continuous. We would have a range of values. If we talked about discrete points, we'd talk about individual plotted points. All of this notation is new and different. And what we're talking about is our independent variable versus dependent variables and how they're related to each other. Well, writing functions also has a new way of writing it. And I don't want you to think of it being any different than writing y is equal to a number or something like that. So if we had this, y is equal to 4x plus 2, if we wanted to specifically tell somebody that this is a function, like no matter what, every domain value that I put into this, every independent variable that I put in, out pops one and only one dependent variable. If I wanted to specifically say that just with writing the equation without actually like having to go into any sort of extra fluff, I could write this. So the way that I have now written this f of x, that's how I say that. I write f of x, or I say a function of x. By writing it like this, I am telling everybody, I'm shouting it from the rooftops, that this, no matter what number I put into this, every independent variable that I put in here, out will pop a dependent variable and only one dependent variable. If I write f of x, I am essentially shouting from the rooftops that this is a working function. It passes the vertical line test. For every independent variable I put in, out will pop one and only one dependent variable. It's kind of cool. So I will write things like f of x and then write the equation that corresponds to that relationship. You'll also see these. G of x, and it might just look slightly differently in terms of equation. You may also see h of x. Each and every one of these is just saying that it's a function. If it's in this notation where I have g, I'm naming this function g, this function g of x is this. So if I put any independent variable in for x value into this equation, I will get out, or into this function, I will get one and only one y value out, or dependent variable out. This value determines what I get out for my dependent variable. So we say this is a function of x, this is a function of x, this is a function of x. These are just functions that are named g. This is a function that's named h. This is a function that's named f. Cool? Cool. New way of writing y. F of x. So great.